Hello guys, so today we are solving this problem. First, completely painted row or column. So you are given a zero indexed integer array L and a m cross n integer matrix. Okay, so we are given one integer array and then a matrix. Air and mat both have contain all the integers in the range 1 to m cross n. Okay, so what would be the m cross n number? That would be the range, so starting from 1. So remember, we wouldn't have any 0 here, we are starting from 1 to m cross n. So go through each index of I in air starting from index 0 and paint cell mat containing the integer air I. So let's make a sense here. So for example, this is the array given to us 1 3 4 2 and this is suppose matrix. So what we have to do is we have to basically we will start for this array from here 0th index, right? So suppose this is 1, right? So we will paint this guy, we will paint this cell. So let's say we are done with the painting of this cell, then we are coming at 3, so we're gonna paint this guy. So let's say we are done with the painting of this guy. Now we are coming at 4, so we will gonna paint this guy. So whenever we found that a column or an row is completely painted, at that time we will return that index. Okay, so at 4 we have painted, you can observe we have painted this column, right? 4 and 3 is completely painted. Similarly, this row is also painted. So at that time we have to return the index. So what is the index of 4? Its index is 2. So our answer should be 2 here. So this is what we have to do is, so we will start from this array, keep on painting from left to right, we will keep on painting this matrix, and whenever we are first time seeing that either one row or one column is completely painted, we have to return that index. In this case the index should be 4, index of this guy 4, which is 2, right? So that should be our answer. This is what given in the question also, you can see here. So they have given this array, same array that I have explained, and this is the matrix. So they painted first 1, then they painted 3, then when they were painting 4, they found that the column, last column or the first row are completely filled. So any one column or row should be completely filled. That should be our answer. This is what we have to do here. So let's go towards the approach of it. So the approach is very simple. What we're gonna do here is, like, first of all, we will store the because these are the unique numbers. If you go on the bottom of it, you can see here that all the numbers are unique. Okay, all the numbers are unique. See, all integers are unique. So if we store the indexes, row and column of every number in this matrix, we can rely that because uniqueness would be there. So what we will do is we will create two map. One is for, let's say we can call it row map, that would be kind of an hash map. One is for row map and one for the column map. Okay, so we can call it column map. So what will happen here is we will go through this this matrix, right? So we will store the row and columns. For example, when we are coming here, for every number we will traverse through it. So we can store here, like, what would be the row for one number 1, the row is 0, and similarly for the number 1, the column also 0, right? So one pair we have stored. Similarly, we can go to this guy, this is 4, right? So 4, what is the row? For 4 the row is 0, and similarly for 4 the column is 1 this time, right? Now we will come to this guy. So what is the row for this? So we can say that for 2 the row is 1, right? And similarly for 2 the column is what? Column is 0, right? Now we will coming to this guy 3. So what is the row? So for 3 the row equal to 1, and for 3 the column is also equal to 1. So in this way what is happening, we have stored the row here for every number in this matrix, and we have stored the column for every number in the matrix. So we are done with row and column. What we're gonna do is, now we have to, whenever we will traverse through this array, basically we will keep on counting of all those occurrence in the row and column. So what we will do is we will create two integer array, like let's say I'm calling row and the column. Why? This would be counting, basically the counting of the every index, means it is row or column, how many numbers are appeared. Okay, so this would be I'm keeping of the size. For example, in the row there are two rows and two columns, so similarly the whatever the size of row and whatever the size of column, you can say this is n the size of row and this is n the size of column. So what we will do is we will keep on increasing whenever a number occurs here. Okay, for example, in this case itself, what will happen, we will start from here, right? This is 0, this is 1. So when we are starting from here, what would be, so at this is I equal to 0, right? So I equal to 0, we have 1, so we will go to the index 1. Okay, so we will check there what is the row of it. So we are coming here at 1, the index is 0, right? Row is 0, so at row 0 we will increase the count by 1. Similarly, what is the column? The column also for 1, the column also 0, so we will increase the count in the column array also by 1, so this also become 1, right? Now we will go to next number is 3, right? So at 3, what is the row? Row is 1 and column also 1, correct? So we will increase the count of 1, this is 1 and this is also 1. Now we are coming at this guy 4, right? So at 4 we will check what is the row. Row is 0 and column is 1, so we will go to 0 first in the row and we will increase it by 1, so this will become now 2. But as soon as it become 2, we will also keep on checking that, hey, is this count is becoming equal to whatever the size of row. For example, here row is also 2 and column is also 2. So as soon as we found that this become 2, that means this index should be our answer, because we got the count equal to size of this column or row, right? So this would be I equal to 2. We will return I equal to 2 as our answer. So this should be our approach, and we are not going here. What we are doing is the time complexity is m cross n, because we are traversing through the matrix which is of size m cross n, and similarly the space complexity also m cross n. So let me show you my corresponding code for this thing. So see here what we are doing. Initially I created these row map and column map to count to keep track of the row and column of every number, and this is for the count purpose, row count and column count, the same thing which I created here. Okay, so we will read it. So see here I'm traversing through this matrix and storing the every numbers row and column in this matrix. Okay, also I'm storing in this row map and hash map. And then what we are doing now, we are traversing through the array, and see here for every row we are getting the what would be the row and column for every number in this array. We will getting it from the hash, row hash and column hash, right? Row map and column map we created. Now what we are doing, in the case when we are getting that row current count plus 1, okay, because anyway we have already got these row and column things, so we gonna create the count of it, increase it. So see here, if it is equal to n, okay, either count of row or count of column plus 1 is equal to m or n, then we are returning I immediately, because that would be our index. If that is not otherwise, then we are keep on increasing their count, just like we are doing here. And finally we would be come out of it, and somewhere this return I should be matched, otherwise we are returning -1, though this condition would be never appeared, as they have sent there would be always a solution. So if I execute this code, let me run it, let me submit it. For watching this video, if you guys have any concern, please make a comment over there. Thank you.